We're in the other part of the business, the aerospace side, and I'll talk a little bit more about how technology and innovation is bringing product, services, and facilities together. When we decided to really expand globally, we looked into this part of the world, and Singapore is our second home. In Seletar, which is the north of this island near Woodlands, we have a 65,000 square meter facility. There's two factories there. One does the high-value manufacturing of the fan blades. So when you look at a gas turbine engine, and at the front you see the sort of the titanium fan blades, that's made here in Singapore. It's very hard to do. The only other factory that makes those fan blades is in the UK. About 200 meters from that facility is another factory where we assemble and test gas turbine engines. 3 different types of engines are assembled, 18,000 parts and components coming in, and 1 engine leaving the building. And the only other factory that makes and assembles the large civil engines is in the UK. So because of those significant activities, it is our second home, and the region and the opportunities with the region in terms of supply chain collaboration is what we're looking at in serving our customers. So we don't make cars, but we do these 3 business units. Civil aerospace, we supply the engines to 35 commercial aircrafts, different types. Right now, there's 400,000 people up in the air that are powered by Rolls-Royce, right now. So there's a huge amount of design and engineering to allow that to happen. We serve defense customers as well for performance and aircrafts. And then there's also another part of the business called the power systems. Diesel, high-speed reciprocating engines. We take about 20,000 on an annual basis into the market, and backup power stations, for example, stock exchange in Singapore is MTU engines. So these are fairly large land-based type engines. But that's not what I want to talk much about. What I do want to focus more about, what is changing. And it's really encouraging to be invited by the built environment to understand what's actually changing in the sort of the conversations we're having with our customers and the kind of facilities that we're going to start adopting into the future. CO2 is a key agenda. Sustainability is a key agenda. And if I look at the sort of the emissions per CO2 across the different sectors, you'll have seen this many times. Power generation and manufacturing constructions are the biggies. And then you've got the others, road transport and so on. Air transport is about 2%. We still have a fantastic opportunity to make this much, much more sustainable for our future. And if you look at the kind of CO2 emissions in the products that we've taken out, so if I look at the datum of a Trent 700 engine, which came out into service around sort of mid-1990s, every single engine we brought out since then has been a reduction in CO2. We spent £1.4 billion on R&D. 2/3 of that investment of that £1.4 billion every year goes into environmental factors. We try and do 3 things: reduce emissions, reduce noise, reduce fuel. Doing one of them is actually really easy. Doing all 3 of them together is really hard. And we've managed that trajectory with incremental innovation. And today we've got the Trent XWB on an A350 engine. It is the world's most efficient engine we have today. And yet we're investing into the future. The Advanced 3 and the Ultra Fan will be a 25% reduction in CO2 from a datum of Trent 700. Our target is not to stop there and to really hit minus 30% of CO2. Some of the kind of technologies that you'll see in the engines that are not out today, but we're building, we're developing, we're testing. I'm not going to go through the technologies that we deploy, but some things to note is materials are changing. We're moving away from the sort of the titanium into more carbon composites and carbon sort of fan blades. We've got high power density gearboxes that sit behind the fan to basically slow the front end down, make the back end even faster. That's how you improve the efficiencies and so on. 10% more efficient than today's most efficient engine. And we'll take this out to the market by 2025. Another thing that you'll have probably heard about is the whole electrification story. And you'll have seen many startups that are coming into the sort of the world of electric flights. And they've got the sort of full electric architecture from batteries to energy storage. We've got a slightly different version of that. We're investing significantly in eVTOL, electrical vertical takeoff and land. It's a hybrid solution. So you're not limited by distance. You still have a traditional gas turbine engine, but you have a very intelligent electrical propulsion architecture that sits around that. And now you're talking disruptive innovation. Because that incremental trend that you saw earlier on, that is not what we're seeking for anymore. We're seeking for a huge step change in the amount of fuel consumption, reduced fuel consumption, and reduced emissions. But the real sweet spot is the regional jets. And this is much more distributed electric propulsions on the wings. You still have a gas turbine engine, but you can now build airports in cities because your takeoff is 1/3 of the size that it is today. Your emissions are significantly reduced, and there's virtually much fantastically reduction in noise as well. So you can start building airports in cities, and you can imagine, especially in our geography of Southeast Asia, that's a huge value proposition. And then as we go further on into the right of the time scale, by 2040, we'll see more electrification coming into the wide bodies. And then there's the digital revolution that's impacting all our businesses in our areas. And when we look at digital, what we're doing is connecting. So one engine on one side is actually connected to the other engine. They're collaborating. They're actually deciding what the power sharing should be. What is the most optimal power share? I'll reduce my trust by this certain percent. Why don't you increase it by so much? And then there's contextual collaboration. So really sensing the environmental data and what's happening around the surroundings and making some really informed decisions. And we're putting that intelligent architecture around our frameworks of the intelligent engine. The other areas that we're doing is collaboration with not just a Rolls-Royce solution, but really bringing the whole value chain of the aerospace activities together. We've got loads of context data, historical data that we're using to make decisions. Wrap that with manufacturing data and maintenance data. We have to look after our engines for a life cycle of 20 to 25 years. We've been collecting data for 25 years now on every single engine. From today, looking backwards, 25 years worth of data, and so you can now start doing some predictive maintenance on the maintenance, and when an engine comes to an MRO shop, how did it actually perform, how can we improve the efficiency even further. Looking at the operational data, the point-to-point types of routes that's conducted, and bringing that with the environmental data, and if you collaborate and bring all that together, not just at engine level, but at an airline level, not at just at airline level, but at airframe and the whole fleet level, you have really unlocked a huge amount of insight. We've already proven this technology with our partners. Safety enhancements, availability of the engine, and efficiencies are all wrapped up. And then there's the factories. 2009, the spade went in the ground here in Salita. 2012 was the first engine that left the building, so we've been operational for about 7 years now. And yet we're investing huge amount of technologies into the factories, even though they're fairly new. And we've invested in the robotics, we're going much more into collaborative robots, man and machine working together. We now do a lot of automated sensing. The design methods are integrated with the workflow. You've got digital dashboards, the kind of things that you would see in many other industries. But the real value for us is to be able to connect that digital thread all the way from the start of the supply chain coming in, inventory coming in. I've got 18,000 parts coming in, digitally codifying it, going through the cells, going through the test, going through into our operators and into Airbus or Boeing, and linking that DNA thread together of the manufacturing. And we're spending a huge amount of investments to be able to improve that productivity even further. And we do this by collaboration. Here in Singapore, there's an institute called A-Star. It bridges the gap between technologies that are developed in universities and industry needs. And that expertise that sits in between is a fantastic sampling type environment for us to really rapid prototype and develop. And one of those sampling environments is ARTC, Advanced Remanufacturing Technology Center. So when we have an idea, we don't stop our workflows. We actually replicate that cell in this sampling type environment at the ARTC. And then we get the solution, we develop it, we validate it, we get it certified and regulated, and then it comes into our flow line and there's that seamless integration. And we've spent quite a significant amount over the last 5 years in partnership with MTU to develop 80 projects that are going to be implemented in a fairly new factory. And that's really advancing with smart manufacturing and knowledge-based manufacturing. And one of the examples that perhaps I can pull out is a borescope inspection. One of the things you may see is when an aircraft lands, you do get two technicians, they go in, one sort of looks in from the front and he puts a borescope in, and the other one's helping to turn, and basically what they're doing is looking at internal inspection that everything is exactly how it should be. It takes about 10 to 12 hours, because you then have to take that data down, you have to analyze it and so on. We've reduced that down to 2 hours, and only one person required. And you literally just put in the borescope now, you spin, you rotate your engine, and in a very short period of time, you've got digital images, you've got pattern recognition, and it tells you exactly where to look. So you really reduce that time. So that's the kind of examples that we're looking at. And it's just not the new build facilities. We have a joint venture with SIA engineering company near Changi Airport called Seisel. We do the maintenance, repair, and overhaul of those engines. About 380 engines come through that shop. We strip engines down, we put it back together, and they continue to be serviced. So a lot of these sort of the innovations that we're going to see is going to be for the new factories and also translatable to the MRO facilities. And there's a huge amount of innovation going on there. This is just another example that we're investing significantly with Harvard University in the US and Nottingham University in the UK. Intelligent robots. And the way we literally will just open up a bag, put it in front of the engine, and they literally go in and sort of do the scanning. They go inside, they come back, they report what they found, and maybe even help with the repair type of activities. And this seems sci-fi, but we're actually going down this route quite significantly. So when we look at our sustainability strategy, it really is about bringing together innovation of the products, innovation of the technologies, and the innovation across operations, and they need to seamlessly start interacting with each other. We can't see them in isolation, and the operations and the facilities are a key part of that. In a lot of occasions, I see the operations always left that there's a back end. We need this facility now because we've designed this and the other. It has to be integrated right from the front end, and that's how we're operating our smart manufacturing processes. And then when we do design a facility, we've got to look at sustainability. So this is the rooftop of my Salita facility that I was talking about earlier on. For the last 3 years, we've covered the roof with the photovoltaic cells. It's, when I calculate the whole sort of the wattage, it's 3.2 megawatts. Putting the solar panels on the roof and over the car park. We're not stopping there, we're doing even more. And we've set ourselves fairly ambitious targets. 0 emissions by 2030 from our facilities. Remember, this is a manufacturing facility. It's an assembly facility. We're taking the test out, but in the manufacturing and the assembly, we want 0 emissions. We're going to reduce our energy consumption by 50% by 2015 against the datum of 2014. We're going to reduce the total solid and liquid waste and achieve 0 waste to landfill by 2020. And that's what we mean when we talk about circular economy across our operational and facilities. So this is about shaping the future. It is about bringing together technology. It is about bringing together the customers and their visions together. It is about designing our factories with that with that philosophy, it is about bringing the digital solutions and the smart manufacturing solutions all together, and not forgetting our supply chain on the left-hand side, and not forgetting our MRO facilities on the right-hand side of that whole value map of aerospace industry. And with that, thank you very much.